Okay, so we're down to the last lesson of this chapter. So, like what I said yesterday, that we're gonna go back to 3-5. We just jumped through to 3-6 because we both lessons deals with equations of the lines. And now let's go to 3-5. And this lesson is just a reverse of what we had uh, in last week, which is about the parallel about the 3-2 parallel lines and their measurements. Okay, when there's a transversal. So let's just review, go back to that lesson. If I'll just show you this one. Okay, so if you can still remember this last time, okay, we have four angle relationships that is formed when a line, when two parallel lines are cut by a transversal. Then we found out that based on the postulate, corresponding angles are equal. Each pair of corresponding angles are equal. Not only the corresponding angles, but also uh, each pair of alternate interior angles and each pair of alternate exterior angles, they're equal. And in terms of the angles who forms a consecutive interior or angles that is considered as consecutive interior angles, we don't expect them to be equal. Rather, we expect them that when we add both angles, the sum is equal to 180. So consecutive interior angles has a sum of 180. So example of consecutive interior are like here, angle 3 and angle 8, angle 2 and angle 5. So you see they are not the same, but their sum is 180. Both pairs tells us the same thing, that when you add them, it's 180. For corresponding, we have 4 and 8, both are 47. 1 and 5, both are 133. Angle 3 and angle 7, both are 133. Angle 2 and angle 6, both are 47. For alternate interior, we have angle 2 and angle 8 equal, both are 47. Angle 3 and angle 5 is the same pair of another pair of alternate interiors, and we see that they are equal. The same thing with alternate exteriors, angle 1 and angle 7, they have the same measurement. Angle 4 and angle 6 are alternate exteriors and they have the same measurement. So that's what will happen if two lines are parallel and cut by a transversal. That's what will happen to the measurements of the angles formed by the transversal and the parallel lines. Now, the lesson today is the reverse of that. So how are we going to find out if the lines are parallel? Okay, provided, let's say, you're not given with the information that the lines are parallel. So how can we say that these two lines are parallel? So we'll go to the lesson today, which is 3-5. So we are now in this lesson, proving lines parallel. Let's say, how can you say that the lines are parallel? So for example, going back to the reverse of what I just have presented, that means before we can say that lines are parallel if we see that corresponding angles are congruent, alternate exterior angles are congruent, consecutive interior angles are supplementary, alternate interior angles are congruent, or two lines are perpendicular to the same line. That means if the first line is perpendicular to the transversal and the second line is perpendicular also to the transversal, then the first and the second lines are parallel. So those are the conditions that we have to meet so that we can say that the lines are parallel. Okay, so we don't need to show all of these conditions, just one of these five. If you can just show one of these five, then we can say that the lines are parallel. Okay, so for example here, it says the measurement, if the measurement of angle 1 is equal to the measurement of angle 2, determine which lines, if any, are parallel. So angle 1 is over here, angle 2 is over here. So the common line between them is M. So we treat M as the transversal of the two lines R and S. So M is the transversal, R and S are the two lines that we're trying to see if they are parallel or not based on the given information that angle 1 and angle 2 are equal. And so if they're equal, we look on the relationship of angle 1 and angle 2. What relationship exists between angle 1 and angle 2? When I say what relationship, right, the question is, are they corresponding? Are they alternate exterior? Are they alternate interior? Or are they consecutive interior angles? So based on that, angle 1 and angle 2 forms a corresponding angles. And so, because it's given that they're equal, if corresponding angles are congruent, then the lines are parallel. The two lines are parallel, not the transversal, rather the lines that is crossed by a transversal. And so we say R is parallel to S. It is the R and the S that are parallel. The M was the one considered as the transversal. And then we can also use the same argument, the same theory in finding the possible values of the variable so that the two lines can be parallel. Okay, let's move to example number 2. This is the most common thing that we have been doing here, making an equation. So find x and the measurement of angle ABC so that M is parallel to N. Okay, the question is, what should be the value of the x so that when you replace x to this, you get the value of this angle. We replace the same x that you have replaced to the first one, you get the value of this angle, right? So what x will make these two lines, will make these two angles measurement that would tell us that these two lines are parallel. So first, we look at the two angles. So what kind of relationship exists between these two angles? This is for this angle over here, 3x plus 10, and this one is for the angle over here at the vertex B, 6x minus 20. So with respect to these two angles, the two angles are alternate interior angles. Okay, so if these two angles are alternate interior angles, for the line that contains these two angles to be parallel, for M and N to be parallel, our alternate interior angles is what is written here. Our alternate interior angles must be congruent, must be equal. Okay, so what is that x that would make them equal? So what is that x that would make angle DAB and angle CDA equal? So therefore, we write measurement of angle DAB, this one here, and measurement of angle C, this is CBA. This is CBA is this. And so it's a 3x plus 10 equals 6x minus 20. Solve the algebra. We have minus 3x on both sides. That gives us 10x equals 6x minus 3x is 3x, then minus 20. Plus 20 on both sides. So the 20 will be eliminated here. That's why the other side becomes 30. So 30 equals 3x, divide 10 both sides, so x is equals to 10. So x must be 10 so that the measurement of angle ABC is 40. ABC is 40, which is 6 times 10 minus 20, 40. At the same time, when you replace x to the 3x plus 10, you will see that 3 times 10 is 30 plus 10 is 40. So the two angles are equal. So only at x equals 10 will make these two angles equal, the same, 40, 40. When your x is not 10, these two angles will have the different measurements. And if they have different measurements, that won't make M and N parallel, okay? Because these two angles are alternate interiors, we want them to be equal. And the only x that can make these two angles equal is 10 based on what we have solved, okay? Using the expression that represents them. We say that they are equal and then we solve for the value of x. And we find the other angle that is asked, which is angle ABC. So again, In this kind of problems, we need to identify first, again and again, what kind of relationship. If they are corresponding, if they are alternate exterior, if they're alternate interior, then we simply put equal sign between the angles, okay? Between those two angles that are said to be corresponding or alternate interior or alternate exterior. But if the two angles involved happens to be alternate interior, consecutive interior angles, then we plus them equals to 180 so that we can find the value of the variable that would make these two angles supplementary, or that the two angles will have a sum of 180. Because when the two angles are consecutive interior, only when they are supplementary, then we say that the lines that forms them together with the transversal are parallel. Okay, so for example here, let's answer some of the numbers here. Let's say number 1. Okay, number 1. What's the relationship between the one with 5x minus 5 and the one with 6x minus 20? Okay, so 5x minus 5 is an exterior angle. 6x minus 20 is exterior angle also. They are on the opposite sides of our transversal. This one is our transversal, so we consider these two angles as alternate exterior angles. And once they're alternate exterior, if two angles are considered as alternate exterior, then they must be equal for the two lines to be parallel. So we say 5x minus 5 is equal to 6x minus 20. And then after that, we do the algebra. We solve for x. So up to you where to put the x. So let's say put the x on the left side. So 5x minus 5, we want to eliminate the negative 5 there. So plus 5 both sides equals 6x minus 20 plus 5. So that will eliminate the negative 5 on the left side. And then what we'll have is 5x equals 6x minus 15. Okay, and since we are solving for x, we want to eliminate the, we choose to put the constant on the right side. Therefore, the other part of that is we want to put the one with x on the left side. So the term with variable x on the left side. So we have to eliminate the 6x on this side. So that becomes 5x minus 6x. We minus 6x because we will minus 6x on the right side. So remember what you're doing on the left, you do it also on the right side. Okay. So this one dictates the minus 6x on both sides. That's why we decided to put minus 6x. Okay. I mean, if you're good in solving simple equation, that won't bother you. This is just a detailed discussion for those who are still struggling in solving simple equation in one variable. And that gives us negative x equals negative 15. We're solving for positive x, divide both sides with negative 1. So x is equal to positive 15. Okay, so x must be 15 so that these two angles will be equal. Okay, we'll check. When x is equals to 15, what happens to 5x minus 5? 5 times 15 minus 5, 70. This one, 6 times 15, 90 minus 5, also 70. So the only x that can make this 5x minus 5 and 6x minus 20 equal is 15. Okay, if your x is not 15 in this problem, they will end up the same. So if they're not the same, it won't make your L and M parallel. They have to be the same because they are alternate exterior, and so that these two lines will be equal. Okay, so first, going back, we have reviewed what we do with the two equation. Okay, what are we going to do with this? Since they're alternate exterior, we put equal sign between them. Okay. So what about number 2? What will be the equation for number 2? We have the 4x plus 20 is for this angle. 6x is over here. What kind of relationship exists between them? 4x plus 20 and 6x. Both are interiors and on the opposite sides of the transversal. Therefore, they are alternate interior angles. So they are alternate interior angles, and so they have to be equal. Alternate interior angles must be equal. So we say 6x equals 4x plus 20. And then minus 20 minus 4x both sides. 6x minus 4x equals 4x plus 20 minus 4x. Then that gives us 2x equals 20. X equals, divide 2 both sides, x equals 10. So when x is equals to 10, you expect that when you replace it to those angles, 6x and 4x plus 20, you expect them to be, that they will end up be equal. So it's 4 times 10, 40 plus 20, 60. Okay, what about 6 times 10? Also 60. So when x is 10, these two angles ends up to be the same. Each of them is 60. And because they are the same and they are alternate interiors, then that makes L parallel to M. Okay, L parallel to M. Now here, this is the combination of alternate interior and perpendicular. So we see that M is perpendicular to this horizontal line. So for L to be parallel to M, it should also be perpendicular to this. So that means the angle formed here must also be 90. So we say 3x plus 15 is equal to 90, or we can say, oh, these two angles on the square and the 3x plus 15 are alternate interior angles. So alternate interior angles like number 2 are congruent. So we can still, if you use that argument, it gives you the same equation, that 3x plus 15 is equal to 90. And then minus 15 both sides, 3x plus 15 minus 15 equals 90 minus 15. So 3x is equal to 75. So x is equal to 25. So at x equals 25, it will make the angle that is represented by 3x plus 15 equal to 90 degrees. Because for L to be parallel to M, it must be perpendicular to the line. Okay, because M is perpendicular to the transversal, then L must also be perpendicular to the transversal, so that the L and M becomes parallel lines. Okay, for number 4 is the same thing. The argument here is its alternate interior angle. So I can type the equation and then you solve it by on your own. 9x plus 1 equals 8x plus 8. Okay, so that's a very easy question. I mean, very easy equation. You can solve that simple algebra there, solve for x. Alternate interiors, okay? There are alternate interiors. Number 5, 2x and 3x minus 20. They're also alternate interiors. So, I mean, alternate exteriors. So once if there's alternate, automatic equal. So 2x equals 3x minus 20. Okay, so that's alternate interior. Okay. And then number 6, 5x plus 20 and then 70. Then, but there's no specific, the L and the M is this one. Okay, but the 70 is for line N. But take note that M and N are, M and N are, M and N are parallel. Because of this, they are parallel. The symbol tells us that they are parallel. Okay, so that means if this is 70 here, this one is also 70. Okay, this is also 70. And then this angle and this angle here are corresponding angles with respect to L and M. So for L to be parallel to M, these two angles that are corresponding angles must be equal. So again, the equation is 5x plus 20 equals 70. Okay, so what if you just want to use the consecutive interior? So if this is 70 over here, if this is 70 over here, then on the other side, on this other side, it means that this angle over here is 110, right? That's 110. I cannot make it smaller. That's for, let me make it red for the angle that is red. This one. That's 110. The red angle is 110 because the blue is 70. Based on this, it's corresponding to this, so that's 70. Okay. So the red is 110. So if you're dealing with 5x plus 20 and the red angle, then that's the time you say they are consecutive interior angles. So if you use 110, then your equation becomes 5x plus 20. Since it's consecutive interior to 110, then when we say consecutive interior, we have to add and then equals to 180. Both equations will give you the same value of x. Okay, so here we plus, but we're not adding 70. Rather, we add the 110 because that's the right angle to add with 5x plus 20. If you use 70, then we put equal sign because with respect to 5x plus 20 and the 70, they should be equal. Okay, because they are corresponding angles. But the 5x plus 20 and this red angle here, which we have agreed that is 110, because 70 minus 180 minus 70 is 110 because these two are linear pair. So this is 110 and 5x plus 20 and this 110 are consecutive interior angles. And therefore, if they're consecutive interior angles, then they must have a sum of 180. Okay, so these are very easy equation. Okay, the only thing, like what I said, only thing is we have to make sure we write the correct equation, because after we have written the correct equation, I know for sure you can solve the simple algebraic equation that you just have in front of you. Okay, that's only solving equation in one variable, and it only requires 3, 4, or 5 steps for you to arrive at a certain value of the variable that is present in your equation. Okay, so I hope you'll be able to answer the classwork, and tomorrow we'll have a quiz. On Friday we'll have our chapter test.